shall look at Laplace function. Laplace function. Laplace transformation. Now, basically, Laplace table is simplified as here function of t, and here these are Laplace transform of functions of t. This is a simplified Laplace table. In the simplified Laplace table, what we'll be having, Laplace of a is a over s. Now, Laplace of exponential at is reciprocal s minus a. Laplace of exponential minus at is 1 over s plus a. Laplace of this is 1, this is 2, this is 3, this is 4. Laplace of a trigonometrical function, or we look at Laplace of t raised to power n. Laplace of t raised to power n is n factorial over s raised to power n plus 1. These are Laplace table. It is a universal table. If you get any other table apart from this table, it is not a Laplace table. Take note of it. Laplace table is given as this, progressively. Now, Laplace of a gives you this, Laplace of exponent 80 gives you this, exponent minus 80 gives you this, Laplace of t raised to power n gives you this. And Laplace of trigonometrical function, that is number 5, Laplace of sine 80. Sine 80 is equal to a over s squared plus a squared. Laplace of sine 80 trigonometrical function. Now, Laplace of, that's number 6. Laplace of cos 80 is giving us s over s squared plus a squared. These are trigonometrical functions. Any ambiguity that differs from this is a wrong table. Take note, you can go to Advanced Engineering Mathematics by K.A. Stroll and you will see Laplace table there. Now also, Laplace of sine hyperbolic sine, sine 80, sine hyperbolic sine is equal to a over s squared minus a squared. That is for Laplace of hyperbolic sine, which is called sine. Now, number 8 of this, we have cos 80. Laplace of cos 80 is giving us s over s squared minus a squared. These are proof and deduction from this. This is the general Laplace table, at least the simplified version. Of course, A can, in some books, like in Crazy, Advanced Engineering Mathematics by Professor Erwin Crazy, A is equal to omega, which in mechanical oscillation, mechanical vibration, and some sort of oscillatory relationship in mechanical engineering and electrical application, we can use omega, which is angular frequency. So this angular frequency can replace A. That is not a problem. But typically, the trigonometrical functions has to take this format. This can be found in your books, advanced engineering mathematics books or engineering maths books. Take note. We want to solve some related problems in Laplace transform. Take note that Sir Laplace, who existed mainly in the 18th century, had a lot of discovery in mathematics, and one of Laplace's discovery is Laplace function of t. Laplace function of t is equal to integral 0 to infinity of function of time domain exponential minus st dt. This was a characteristic formula that was used in the deduction of this table. This table was actually deduced using this model, this 0 to infinity of function of time exponential minus st differential t. If we are to find Laplace of a, we induce a here and multiply with exponential minus st dt to get the answer. S is the Laplace itself. S is the Laplace. So now you may be given question 1. Find Laplace of exponential 2t, Laplace of exponential 2t plus t raised to power 2 minus Laplace of sine 4t plus Laplace of cos 3t. If we are given this typical problem, you don't need to go back into the relationship again. We don't need to go back into the relationship again. All we do is to pick it from the table, the Laplace table itself. Pick it from the Laplace table. We are going to pick it from the Laplace table. And the Laplace table, as you see, we can now break it down. We break it down to give us Laplace of exponential 2t plus Laplace of t raised to power 2 minus Laplace of sine 4t plus Laplace of cos 3t. Laplace of cos 3t. Cos 3t. Now, we are going to break it down. Breaking the bracket down in piecemeal to enable us to use Laplace table to solve them as a problem. Of course, the Laplace of exponential 2t from the Laplace table, which is a connotation of exponential 8t, this simply gives us 1 over s minus 2, because exponent 2t is 1 over s minus 2, which is exponent 8t is 1 over s minus 8. Now, plus Laplace transform of t raised to power n is n factorial. Are you seeing it? It is n factorial over s raised to power n plus 1, and that gives us 2 factorial over s raised to power 2 plus 1, because n is equal to 2, which is the power of t, plus, now there is a negative sign here, minus Laplace of sine 80 from the table. Sine 80 is a over s squared plus a squared. So a now is 4. So we now have 4 over s squared plus 4 squared, which is 64. 4 squared, sorry, that is, you can leave it as 4 squared. And 4 squared is 16. 4 squared is 16. At this level, you can leave it this way for clearer understanding. Then plus Laplace of cos 3t. What is Laplace of cosine? Is s over s squared plus a squared. That will give us s over s squared plus 3 squared. Now, this is the simplified breakdown of the Laplace question that we are given. We'll now begin to simplify further. Now, this will give us 1 over s minus 2 plus 2 factorial is 2 times 1, which is 2 over s raised to power 3 minus 4 over s squared plus 4 times 4 is 16. 4 times 4 is 16 plus s over s squared plus 9. Of course, you can leave your final answer this way. You can leave your final answer this way. This is the final solution. You can also relate by finding the LCM and simplifying further. But if you leave it at this point, this gives you a full mark in Laplace transformation. Take note of the Laplace table and take note of the work we have just done. And that the general condition for Laplace transformation is integral 0 to infinity function of time domain exponential minus st dt, where s is the Laplace itself. Take note of the work that this transformation is exponential 2t, which is likened to exponential 8t. Assuming there is minus here, we will have used the value in table 3. So these are applied, this function will use the table value 4 to transform t, table value 5 to transform sine 4t, table value 6 to transform Laplace cos 3t, and we'll simplify further until we get to the final expression. If you care to simplify by finding the LCM and multiplying throughout to get a numerator and a denominator, it's okay. Otherwise, if you don't have that capacity or you're not even interested in progressing, you'll get a full mark here.